In this given video, we are going to discuss a very important component throughout our session, which is which we will be using as a main part in our future UVM designs when we will try to implement the whole architecture of UVM classes. Like in case of system Verilog, you have a transaction and other you have a driver, you have a interface. So interface consists of all the bundles of the signals which we wish to transfer to the DUT. So we itself have a DUT, we have a monitor, we have a scoreboard, we have an environment class, we have a test class inside which we will take the instance of this environment, create the object. Okay, so this is a workflow of system Verilog test bench. However, inside here we have a UVM little bit different items. We have a UVM sequence, SEQUEN sequence item. This actually refers to the transaction object. It has a rule of considering all kind of randomized signals of our design. It itself does not do anything. Whatever the randomization will happen itself will be UVM sequence only. So we have next is UVM sequence, inside which we will just randomize all the signals and we will send to the driver. And then we have a sequencer, UVM sequencer. It itself explicitly we do not declare it, or you can declare it. It has a role what that it transfers the packets from the sequence to the driver. So we have here UVM driver. So this one is a dynamic component. So for this one and this one we use the UVM object util, and for other also we will use we will use UVM component util. So we have a UVM sequence, UVM sequence item, UVM sequence, UVM sequencer. So it itself has no role, it just transfers or say forward the data that whatever that are randomized by the sequence to the drivers. Then the driver sends to the DUT. Then inside we whatever these all three items are considered contained inside the UVM agent. Then we have a UVM monitor, which we are going to just do what we will just take the interfaces from the DUTs. We will communicate everything using UVM config DB and interfaces, and through TLM UVM port analysis port, and we will just see what the values we are getting from the DUT, and inside the scoreboard we will compare them. We have inside UVM scoreboard. Then all of this is contained inside the UVM environment. After that we will just stimuli generation, and rest other we will do inside the UVM test case. Okay, so this is the main workflow of the UVM test bench. These are all the classes which we will create inside when we will create any big project. I will start from the adder itself, but for now for the starting purpose you need to understand the role of these main component. Then slowly we will move ahead to the other components also. Now let us create a simple transaction object. So class my sequence, you can say extends. Now you will extend to the UVM sequence item. Okay, so I will just declare it to the object. First we will need to create the items. Rand say rand bit 2 down to 0. This is data. Okay, and this is rand bit 3 down to 0. We have a address bit here. Okay, which we will randomize and send throughout, which will be randomized inside this UVM sequence, and this sequencer will transfer to the UVM driver itself. We will see for now today the basic part will be just to see these things, till these things only to the UVM driver. Though we are not going to use the interfaces also, that we will share throughout our duty, that we will share those interfaces to the transaction object, but we are not going to do that. Now we have done it, created two items here, data types here. So now we will just do what UVM, just register all these two components to the factory. UVM object utils begin, I will here as my underscore sequence, and let me just write it as UVM object utils, and okay, I have this two objects data types, so I will just use the double cursor functionality. I will write UVM field int, and inside this I will just name it as I will just change later. So the type is UVM default. I will just write here as address only. Okay, one second. So we have registered all those two data types to the data to the our factory. Now we are going to just create the constructor for it. UVM function new, and here we have a string name equals to just, let me just write it as a UVM my sequence. Okay, and function now is called super.new method, and I will just pass name to it because UVM object itself contains a single parameter, and that is name only. UVM component contains two parameter, that is name and that UVM component, that is path, either null or this. So our major work, so first component is done, that is UVM transaction object. We have now created the transaction object. Now we will create the UVM sequence for us. Class let's say my let us say like core underscore a sequence, I will name it as extends UVM sequence. Now I will need to pass the data types on which it will work, so it works on the transaction object. So transaction object, for that I just need to pass this as an argument here, the my sequence here. Now one second, let me just get some space here. So this is also the part of UVM component, so I will register to the UVM object, UVM object. So UVM object utils, pass this class to the factory, and here this is done. What I will do here is let me just create this function, copy paste it here inside also. One second. So here I will just write as core underscore a. Okay, now inside the task body, now whatever the body is a function inside which you actually declare all the declare all your work that you are intended to do. Okay, and the task and class. Let me tell you the whole sequence. Here I have taken the help of ChatGPT. I have created the whole sequence of how this transferring of data actually occurs. It is not that you will just keep on sending. There are some other arbitration also. Right now we are only dealing with a single sequence and a sequencer. In the further lecture, when I will extend it to the advanced work of the UVM sequence, we will see the multiple sequence, which sequence executes first, and let us say you want to block the execution of some sequence, you want to execute the some other sequence. So in those cases you just need to learn about the UVM sequence arbitration mechanisms. Generally we have this random mechanism, user defined mechanism, FIFO, strict FIFO. These are some of the UVM's standard sequence arbitration. We will also discuss this lock and grab method also we will use when you want to just block the execution of, when you have a multiple sequence and a single sequencer and you want to block the execution of single any of the sequence or class that you want to avoid not to happen at that instance, then you use this lock and grab method. We will discuss separately in next further videos, or if you want to discuss more about these topics also, right now I've just mentioned them, you can discuss by study them by your own self. Okay, Now what happens, if you just see inside the sequence, you just create the item. So and then you just send the request to the sequencer whether it can it send to the driver, because whether sometimes you can know that driver is sending to the item to the duty, so whether it is free or not. So this is a complete sequence. If driver is free, then it will say that get next item, then sequencer will grant the sequence and it will randomize the center next item to the sequencer, and then everything will be like this flow only. Okay. So there are other functions also, but in general the very other engineers use this function only. So what I am going to do is I will just create a object of this my sequence, my underscore sequence, let us say req only. Okay. Now what I am going to do is I will just repeat 3 times. I will create the object 3 times and send it, because single object that itself doesn't make we can create a lot of objects at a time, so that we can easily analyze all kinds of functionality what is happening inside. So I will just do this, and I will just create a request. I will just create the object for it. This is type underscore id create, I will say here request. Now what I will do is finish sorry what I'm going to do is start underscore item. Now this is a function, I will discuss about it, but let us just write it here, request. Now and this I will just pass this transaction object to the here, and now I will just do assert this req.randomize. Okay. It will tell us whether the what say our assert will itself, it will just give the output as 0 1. So assert will tell us whether our request is randomized or not. Okay. So I'm not right now adding else case, because I know that it will get randomized. So I will just call the finish underscore item method. Okay. Request. Okay. Now these these function actually indirectly do the whole work by itself only. The start item and this finish item itself contain all the functionality itself, that create item, then it randomize it, then send request to the wait to the next and get response. All of these are itself contained inside these two function only. So it's explicitly we do not need to just follow up this order. You can try this on the chip verifier or other websites, or I can post it, or I will tell about this on a shorter video. But right now they are not that much important, because using these two simple functions only you can execute all the steps that are written here. Okay. And now our objects is created. Now I will, okay, our half work is done. Now I will create a UVM sequencer class core underscore sequencer. Now you can also study about this m underscore sequencer and p underscore sequencer handles. These are also important when I will use those lock and grab method. I will tell about them. So UVM core sequencer extends UVM underscore sequencer. It will work on the transaction object. So I will just say what we have mi underscore sequence. This is a UVM object. So I will just declare register to the UVM object factory. UVM component. UVM component utils. I will just register to the factory here. Now I will just copy this function method and just pass one extra argument here. So string name core a, here we did not have my sequence. Core underscore sequencer. Okay. Now I just need to add the extra parameter also, UVM component parent. So I will just add here also parent. Now this does not have a lot role, so I will just declare it here only. Now right now I am not creating the agents and environment, so I will directly create a UVM test class my underscore test extends so UVM underscore test. One second, I just need to declare the driver also, because inside the driver we just want to just say that it is collecting the object. So class my underscore driver extends UVM underscore driver, it is working on the transaction object that is my underscore sequence. Okay, so end class, this is a part of UVM object, so I will just copy this whole part here and just replicate the same exact here. I will just copy this and paste that driver class here, also driver class, rest will be same. Now inside this we need to mention this run phase, task run underscore phase, UVM underscore phase. So whatever the sequencer is providing us, I just need to collect all those items here. So end task here. Okay, I will create my underscore sequence request object here. Now I will just say forever, because we know that it is working 3 times, but right now we do not need to do it. It will itself terminate itself. Forever begin and end. Now use this function sequence underscore item underscore port dot get next underscore item, and here you will just write the request. Here you will write your DOT work, but right now we don't have an interface, so we do not need to do them. So UVM sequence item underscore port dot item done. I will just see I have okay. Now this is get next item and item underscore time. This is done our part. Now I will just create inside this. One second, we have a driver. Inside the driver, I guess we have done all the things. Okay, inside this we will create the instance of all these core sequence, sequencer, and this transaction object. This is core A, core underscore A. Sorry. So A underscore sequence, I will say. Now we have a core underscore sequencer, I will say SEQR. I have a my driver, I will say DRV. I will just register to the factory the same thing. This here we will have a my underscore test. Now inside the build phase I just need to create the objects of all of them using this UV factory functionality. UV function void build underscore phase UVM underscore phase and function here dot super dot build underscore phase. Now I just need to do what? I just need to create the object for them. So we have first 1, 2 and 3. So I will just create one and there's a replicate others. We have a core underscore A type underscore ID create. So A underscore sequence. Okay, so this is for A underscore sequence. This is for SEQR. Okay, SEQR. Since this is a UVM object, one second. Okay, now I understand. This is a UVM object. Okay, I remove this from here. This is a UVM object. So for that, I just need to add extra parameter, that is this. Also, now we have a driver DRV and this is also UVM component, so I will add this here. Everything I guess is fine. Yeah, now the indentation is correct. Now inside the build phase I have created the objects. So what I will do now, I will just start the connections, and now it itself does not start automatically. There is a syntax that is sequence underscore name dot start, then it is just name here a sequencer underscore name, that is whatever you have created. So just do what, I will connect a driver inside this connect phase. So for that, a underscore sequence dot start seqr. Now I have started our work. Now inside this connect phase I just need to connect it. Function new, sorry, function void connect underscore phase UVM underscore phase and function. uh, Here I will do what, driver dot, I will connect driver to the sequence underscore item underscore port dot connect. I will just connect this to the sequencer to sequence underscore item underscore export. This is the port part and this is the export that is transferring. Okay, it has just work of to forward the data that we have discussed in our previous lecture. What is the work of the export in that UVM TLM? So this work is done. End class item underscore done. If these functions are correct, I'm just having a little doubt whether this one is name is correct or not. UVM will itself tell us. So I just need to add one separate functionality. Sorry. Now once you write the UVM module in run test phase, run underscore test, so in that also you just need to double quotes this name. But in order to avoid this, you just do what, UVM test name equals to my underscore test. Now you do not need to just explicitly inside this module give the name module tb and module. Now inside here, whenever we do initial run underscore test, now this time we do not need to pass that class name as the argument, because I have explicitly defined that UVM test name is my underscore test. Okay, let us see what I will do. Since we are creating, so I will just call the UVM info macro. This is core underscore a. So I will say $ps printf. I will say core underscore a sequence data equals to 0x percentage 0x comma address equals to 0x percentage 0h. Okay, and I will say request dot data comma request comma dot address, and I will just UVM low, verbosity as UVM low. Okay, I will just copy this, one second, copy this exact part inside the driver also. This is the driver UVM core drv. So core driver see data core driver received data as this and this. Okay, so we have created this. Let us try to run this one. I still have some doubt somewhere, so that whatever will be issues, it will itself tell UVM underscore test name. Okay, package function and task 1116, looks like somewhere issue. 1116 function, what it trying to say function cannot enable a task. Uh, One second. So if I am missing whether one second, this is a given sequencer. This is the line of 116. So I guess I am missing that. I should have been running this inside the run phase only. Okay, but okay. Task run underscore phase UVM phase and the task phase dot raise underscore objection this phase dot drop underscore objection this. Inside here I will just do what a underscore sequence dot start and I will just connect to the sequencer. Let us try again. Is it working or not? One second, I get it is stuck somewhere. Let me copy the code whether it should not get demolished. One second, let me just okay. One second. Let me connect to the Wi-Fi. Yes. Yeah. Let me try again. Okay. Incompatible type assessment. One second. 111. 111 sequence. Okay. I have not corrected the name of the classes. Core underscore se un sequencer. Core underscore. It should not be core underscore. It is my underscore driver. This is why every time I do this run, in order to just find what are mistakes, the run time only, that I can correct my mistake. Once again, this network issue. Just one second. For now, let us me try to. What? This has an option is ridiculous. One second. If it not work, I just need to connect to the my Wi-Fi only. Okay, give me a few seconds. I'm just trying to connect it. One second. One second, let me just refresh the given page. Let me create this new one. Okay, I will just copy the exact code here. I will just do what was the name? My underscore test. My underscore test. I will just write it here. Please select the valid simulator. Okay. UVM 1.2 here. I'll take a variable. Run. Okay, there is no error. Okay, UVM sequencer connection null pointer access. Issue factor error runtime. Let us go through. We have created the transaction here. Here we have a UVM sequence. So I've created for the object here UVM object function name. My task body I have declared here. So I've created this request object for the my transaction. So I've started this and then assert this UVM info and this. Okay, this is fine. Now finished item. I've called created the UVM sequencer class, extended to the UVM sequencer. Now I have UVM driver class, so it works on this in data type, transaction data type. So my driver inside the run phase I have a forever. I can do phase dot raise objection, phase dot raise underscore objection, and phase dot drop underscore objection. But that shouldn't be that much problematic. Sequence item port get next item. Item underscore done. 1 second. Let me confirm whether the given functionality is correct or not. Because item underscore done. Oh, yes, everything is, I guess, correct. Sequence item port gets net item. Sequence item port item underscore done. So this is correct. So finish and start. That finish and start also correct. Then here we have this get next item here my test class. We created the instance for the core A my driver drv, and this is core sequencer seqr. Now inside the run phase I have just did what I have started the sequence. Let me check once again why this is not working correctly. This inside the test I will create the run phase. This is correct phase rate objection. I have said that this sequence is starting start and I have just passed the sequencer object seqr. I have created a sequencer object. Now inside the connect phase I have done what driver instance sequence item port dot connect sequencer sequence item port underscore export. This should be working fine. Let me try once again. Unexpected token 87. 1 second, I just need to call this one outside here. Transaction object. Remember drop objection not found in phase. 93। अरे यार वो भी 6। Okay, this time no error. That null pointer access. Even sequencer connection null pointer access, why? अरे यार एक सेकेंड, मैं इसको कॉपी ही मारता हूँ चैट जीपीटी को, नया अपन लोग दिखाते हैं, इससे पूछते हैं कि क्या गलती है, मेरा दिमाग खराब हो गया। 1 सेकेंड। मिनिमम दिस इज क्रिएट माय सीक्वेंस का व्हाट इज डूइंग ब्लॉक बाय ब्लॉक। You go sequence correct my driver correct, but there is a serious bug there. My test extends uvm underscore test create sequence has a typo that will break this connect phase is misspelled। चला, अच्छा कहाँ गया, तभी मैं कहूँ कनेक्शन इस्टेब्लिश नहीं हो रहा है। ठीक है, लेट मी ट्राई दिस वन अगेन, वंस अगेन। अब देखते हैं। ठीक है, डेटा कहाँ गया, हमारे पास कोर ए सीक्वेंस है जिसमें डेटा सेंट ये है और एड्रेस सेंट ये है, और ये हमारा ड्राइवर का है, ड्राइवर ने डेटा ये रिसीव्ड किया। ठीक है, थ्रू सीक्वेंसर, तो ये सीक्वेंस ने डेटा ये जनरेट किया और ड्राइवर ने ये सीक्वेंसर के थ्रू ये एक्सेप्ट किया। तो ये हो गया हमारे पास 3 जनरेटेड ऑब्जेक्ट्स और ये ट्रांजेक्शन ऑब्जेक्ट्स, और ये हो गया हमारे पास ड्राइवर ने इनको रिसीव किया। ठीक है, बाकी जब हम लोग वर्चुअल इंटरफेस क्रिएट करेंगे तो उनको वर्चुअल इंटरफेस के थ्रू डीओटी को पास करेंगे। ठीक है, काफ़ी ज़्यादा बग्स हो गए, कनेक्ट फेस की स्पेलिंग ही गलत थी, वही में दिमाग ख़राब हो गया, क्या बात थी। ठीक है, तो आज हम लोगों ने डिस्कस किया कि बेसिक आर्किटेक्चर की ट्रांजैक्शन ऑब्जेक्ट सिस्टम वेरिलॉग में ट्रांजैक्शन होता था, लेकिन आज हम लोगों ने यूवीएम देखा कि इसमें यूवीएम सीक्वेंस आइटम होता है, यूवीएम सीक्वेंस होता है और यूवीएम सीक्वेंसर होता है। फ्लो ऐसा रहता है, यहाँ से ऑब्जेक्ट्स हम लोग बस आरटीएल के आइटम्स लेते हैं, यहाँ से ऑब्जेक्ट्स को रैंडमाइज करके सीक्वेंसर के थ्रू ड्राइवर को ट्रांसफ़र करते हैं। ठीक है, बाकी हम लोग ये जो कंपोनेंट्स हैं इनको बाद में देखेंगे। ठीक है, तो ये रहा आज का हमारा लेक्चर। ठीक है, थैंक यू।